Hello, grade 11. So today we're going on to solving more advanced trig equations, working from slides 134 to 137 from the trig PowerPoint. Okay, so don't freak out that it's saying more advanced. It's not really that bad. All they've done is they'll just add an extra bit of information. Okay, but you've done things like this before already. So the first example is saying determine alpha to the nearest degree if cos 2 alpha is equal to negative 0,866, where tan 2 alpha is less than 0 and alpha is an element from 0 degrees up to 360 degrees. Okay, so what I'm going to do first is I'm going to solve this equation just normally how we would, okay? And we do that by using our general solution for cos, okay? So we go straight into it. So it's this, whatever our angle is, 2 alpha is equal to plus or minus. And what we're going to do is we're going to go shift cos that number over there. So make sure your calculator's in degrees. Shift cos negative 0.866. And they're asking us to the nearest degree. So I'm going to make it 150. So plus or minus 150 degrees plus K360. All right. Now, what I need to do now is I need to use this bit of information that they've given us there. And what I'm going to do is I'm just going to draw up a little cast diagram. And this will help me decide which quadrant we're in. So this is a negative. I'm going to mark that with a tick. So where is cos negative? Well, cos is negative in quadrant 2 and quadrant 3. This one here I'm going to mark with an X, and it's saying where tan 2 alpha less than 0. In other words, where is tan negative? Tan is negative in this quadrant and in this quadrant. Where do they both agree? Over here. So we know that we're in the second quadrant. And what I can do now is I can eliminate one of my solutions here, because we have plus 150 and negative 150. Now, negative 150 will be in the third quadrant, because you remember you go clockwise with that. So that will be from 0 to 90, or negative 90 to negative 180. So that will be in that quadrant there. But we can't have it in that quadrant because they both agree here. So if we look at the plus 150, we know that's going from 0 to 90, 90 to 180. We know that's the one that we're looking at. So we know that 2 alpha must be equal to 150 plus K360. Okay, and I'm just going to add the plus in there just to show you that because we are in the second quadrant. Okay, all right, so now what I can do is now I can solve for this. So what I'm going to do is I'm going to divide by 2, and we get that alpha is equal to 75 degrees plus K180. Remember to divide this by 2 as well, okay? Now I can't take that any further, so I must say that K is an element of the integers. And because we have a restriction on our alpha, alpha is an element between 0 and 360, I have to choose values for K, all right? So if we choose for when K is equal to 0, we're going to get, if K is 0, we're just going to get alpha is equal to 75, all right? I'm just going to check with our interval here. 75 does lie in there, so that is a solution. I'm now going to go when K is equal to 1. And if K is equal to 1, we're going to get 75 plus 1 times 180. And we get 255. Let's check our interval. 255 definitely lies within that interval, so that is a solution. I'm just going to go where k is equal to 2. So we're going to get 75 plus 2 times 180. So I'm just going to change the 1 to a 2. And we get 435. And you can see that is outside our interval there. So that is not part of the solution. There's no point in going when k is 3, 4, 5, etc. because it'll be way out. Okay. Now, are we going to maybe choose k is equal to -1? Well, if I make it -1, I'm going to get 75 minus 180. And you can see that's going to be less than 0 anyway. So there's no point in checking when k is -1, -2, -3, and so on. Okay. So we're only getting our 2 solutions there. So we're going to say that alpha is an element, curly bracket, and then list it from smallest to biggest. So we get 75, and the next one is 255. And there we have solved it. So you see, it's not too much more advanced than what you guys are already used to. We've just given that additional bit of information that is going to help us decide which quadrant we're in. Okay, going on to the next example, example 2. Example 2 is saying answer to 1 decimal place. I'm just going to make a note here, 1 decimal. Determine x correct to 1 decimal place if x is an element from 270 up to 316 and sine 2x minus 15 is equal to negative 0,546. Okay, so what I'm going to do is I'm going to solve for this bit first, and then we've got our interval, and then I can choose values for x. Okay, so the first thing I'm going to do is write down our general solution for sine. So it's going to be whatever our angle is, which is this. So we have 2x minus 15 is equal to shift sine of that number there. So we go shift sine shift sine negative 0.546. And we're getting negative 33. And I'm going to round it off to 1 decimal, so negative 33.1. So negative 33.1 degrees plus K360. Or the other one is going to be 2x minus 15 equals 180 minus this value over here, which is negative 33.1. Sorry, grade 11, so I'm just going to go to the next line here, plus k times 360. Okay, so let's simplify this side over here. I'm going to take the 15 to the other side, or the negative 15, and we get 2x is equal to negative 18.1 degrees plus K360. This one over here, take the negative in and it becomes a plus. So we get here 2x is equal to, so I'm going to do this all in one step. I'm going to say 180 plus 31.1 plus 15. Okay, and we get 228.1 degrees plus K360. Still want to get the x on its own, so I need to divide by 2, and we get x is equal to minus 9.1 plus K180. Remember to divide that by whatever the number is in the front, and this one here we'll get x is equal to 114.1 degrees plus K180. Okay, so now we've got our general solution. I must just say here that k is an element of the integers. Now what I'm going to do is I'm going to check with our interval here, okay, for both of these. So let's check when k is equal to 0. So when k is 0, we're going to get that x is equal to negative 9.1. and the other one we're going to get x is equal to 114.1 degrees. Okay, so as you can see, none of these lie between 270 and 360. So both of those are out. I'm now going to check when k is equal to 1. So we get negative 9.1 plus 1 times k180, or times 180, okay? And we get 170.9. The other one we will get 114.1 plus 1 times 180, and we get 294.1 degrees. Okay, this one does not lie in there, so that is not a solution. 294.1 definitely lies in there, so that is a solution. Okay, now what I'm going to do is I'm going to check when k is equal to 2. Just want to check that I got this one right. And that is right, yeah. Okay, so now let's check when k is 2. So we get negative 9.1 plus 2 times 180. And we get x is equal to 350.9 degrees. And then for this one here, we'll get 114.1 plus 2 times 180. And we get x is equal to 474.1. Okay, this one is definitely out. It's bigger than 360. This one here does lie between 270 and 360. Now, grade 11s, I'm not going to go when k is 3. This one just made it, so obviously the next iteration is going to be well out. I'm also not going to check when k is negative numbers, because we've only got from 270 to 360. They would be well out. Okay, so there's our two values there. So I must just write up my solution. So x is an element. List the smallest, which is 294.1, and our biggest is 350.9. Okay, cool. So we've solved for that. Now, question B is saying determine cos x correct to 3 decimal places. So we want to find out what is cos x equal to. Well, we've already solved for x in question A. And our x is these two values here. Okay, so I'm going to take these two values and plug it into here. So for the first one, when x is equal to 294.1, we are going to get that cos 294.1. So I've just substituted that in there. And we would get, they want us to round this off to 3 decimals. Okay, so cos 294.1 and to 3 decimals, that's going to be 408. All right, now let's test for the, or check for the other x value, which is 350.9 degrees. And we get cos 350.9 to 3 decimals, that's going to be 987. And there you go. We have solved for cos x. Okay. Right, grade 11s, I would like you to do exercise 7.11. Numbers 1, 4, 8, 12, and 19 for me, please. Thank you.